course, lovely people. Let's look at this punch shearing. You can look on Google, find this image there. Just instead of thinking of as punch shearing, I'd like you engineers out there and fellow followers to think of this as a critical shear failure and the critical critical shear failure and the, let me roll notes here, I'm looking at function, punch shear, protection, and the critical shear area. Instead of just think of it as the punch shearing through the column, which this is not. This is not punch shearing to there. It's out here at the critical shear area. It's out here. So this is not punch shearing failure. I know that's a weird thing to say, right? What's the real failure? This is what's left behind, and this is what we're looking at. But what really happened here? It's the connection that failed. This worked, but the connection from the tributary area to the connection to the critical shear area, let's just put some steel in there if we will, it separated. What caused the separation? What caused the separation? A deflection in the deck, more than likely pulling down, caused the separation here. You can use deterioration and all the, I don't know what this exactly looks like. It could be deterioration, it could be too large of a span, it could be concrete that's not strong enough, like as in 2500 psi when a 5000 psi would have been better. I will talk about that in future videos, why psi matters, that the increasing the psi will stiffen your deck. It will stiffen your deck because I'm going to talk about it in future videos, not fully in this one. But here's rebar here, and let's just call this the concrete. Let's do another little section here. I guess I'll give it a little nice big taste of it. And let's change the color of that side to that one to just blue. All right, and here's our steel. So our steel was put that. I'll use red. I know I could use another color, but let's use red there. That's the steel. And let's box this. Ooh, you can stay over there then. Let's box this to give it a nice look in concrete, if we will. And I should have done it differently because I can do that differently. Let's bring that. Oops. Let's grab this. Oops. Okay, I'll take it from the other side. Yeah, that works for me. Let's put it over there, and then let's do another one here, and like that. And let's give it a different color so we can track it. How about green? So I should make them both green then, this one and that one. Oops. So we'll make this one green also. That way you can keep track, you won't get confused. So now that's the concrete, and it's got a fracture in it. Why? Because this steel is deflecting because of the load of the span is too great. Here's the span from here to here is our spans, and that could be a support there, and well, that could be a support there. So between these two is a shorter span. So maybe this didn't fail first. You'd have to actually see the damage ahead of time. Maybe this side failed first because it has a greater span. I like to pick on the greater span. But nevertheless, here's our fracture. Here's a fracture. And let's get rid of that. So there's a fracture. And let's consider this right here. Say this is 3000 psi, right? So I could have did 3K, but let's do that. The concrete's 3K. This, as it deflects, as the deck deflects, right? As it where are you? Deflection, ding, 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 ring, 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 ring. Okay, they're just cycling, if you will. As it deflects, this crack, you get nothing for free. You know that's my motto. You get nothing for free. A crack is not for free, even though they'll tell you, oh, keep an eye on the crack. If it widens, it's an issue. If there's a crack there, it will widen because a crack was developed. And they developed the crack. You would see it from the underside. You would see exaggeration now. It would be like that. And that's the underside of the crack. Of course, this would be tight. And it would be very, very sliverish. Let's do that. So it would be way down there, the small cracks. As it develops, for it to develop, this up top will have to start spalling off concrete. So up top, it would be more like this. Let's just have some liberty there. And the bottom would be much tighter. The spalling would be like that up top, and the bottom would be that tight, small crack, initial small crack, because it's being resisted by the compressive force of these two butting heads, butting into each other. They're both butting each other because the crack is there now, and it's stopping it from going down anymore because of the crack. And I show that in a video. I should have loaded it. That'd have been a nice segue to it. Okay, I wasn't prepared to do this part of it. And the point is, this is 3,000 degrees. Okay, I'm gonna stick with it. Butting against 3,000 psi, and if it was 5,000, it would be more resistive, a little more brittle, but still you get the higher compressive rate. So it's going to be able to take a lot more before it deflects. So if I would put epoxy in there, 60,000 psi epoxy, it's still 3,000 on that side and 3,000 on that side. It's just that so it will push the fracture on either side of the epoxy. Epoxy not being the one that's going to be crushed by the forces here. It will push it to the other side. When you epoxy it, you'll find the crack other side of it. Still at the same deflection, it's still going to be there. The crack will appear on the opposite side of your epoxies. It will present itself up there. Maybe not in short order, but in order, it will get to there. So this, what I'm saying is not a punch sharing failure, is because it's okay. The deck failed around it. The deck no longer can engage and hold on to this transition over to the critical shear area, and this would be the column head and the shear head if you want to consider it that. But it's a column, and the shear head design is the rebar. Over here I got a video coming out. It's already on the other channel, but I want to show it to you here. Let's thumbnail it here. Punch down around it, right? It doesn't punch down around the... Listen to myself talk. Around it. Let's grab a page. I'm going to grab a page. Sacrifice itself for us. This page would be there. So now, this would be the critical shear area where they build up the extra reinforcement and then go over to the tributary area, the area from this area to the next critical shear area and then to the column. And they don't use extra reinforcement to get over to there besides here. So think about it. They're saying the loads are going to be greater in this critical shear area, this extra piece. But only here is where we need to resolve it because it's going to want to pull down around the column. So let's make this really strong. And then you look at the images of punch shearing online and you see things that look like this. Over here to the left. Where some of them look stripped down like that. And then some will look like that. We've seen that where you see this capital, if you will. It's not a capital, it's part of the deck. Right here. Capital will be the part that's under here holding it. It's the critical shear area. That's the extra reinforcement. Why did it stay and the other deck went around? Because this was so rigid. So much extra steel, same thickness as the deck, slab, same thickness, that when the deck deflected, instead of deflecting back here now and driving down like I showed you here, it now has, this is so built up, so, well, good, if you will, stiff, that the deck is deflecting, out here at my elbow, it's deflecting, but now look the point, the moment is out here. Look here. See my elbow turn? And the moment is out here, no longer is it here, where it's the weakest. When this deck deflects, it says, oh, we've run up against something that's not bending. And so it says, we'll take it here then. And this is where it bends, and then ultimately it gets so much bending. Remember, the rebar is still going to pull out. It's still going to do what it did here. When it bends down, the force multiplier is underneath. You'll see some spalled concrete there, perhaps, beforehand. Okay, I'll say that for you guys to pick up another time. Look to the left. So over here in the left again, let's hide that guy's ugly face there. Hold on, dude. Let's get rid of that. All right, so that's myself. I don't really mean I'm ugly. No, I don't have self-hate. So to the compression now. So it runs up to here. Say it's 3,000 psi. The deflection is the issue here. So it's not here that needs to be reinforced. This was taking that load. It's out here that needs to be reinforced at the crack, but not over here. All you did, reinforcing it over here, you're thinking, oh, I'm capturing the deck from falling by bringing it into here. I'm a capture. Well, all you did was push it out again. You pushed it out again over to another location. This whole deck would have to be reevaluated. In other words, the short version is you look for cracks. If they're around the columns at this configuration, and you look at the ceiling, and then and they kick off like this or kick off anywhere there, it's talking about deflection. It makes it to the tributary area, let's say the center span, if we will. Then you're talking about deflect issues there. You look for, you want to know it's a two-way slab. They usually come in about a 45 when they do that. One-way slabs, depending on the loading, you'll see a repetitive trundles and the above your head, and so we have you have the deflection over here. Again, if you try to secure it and grab the pad that's over here, you're like, oh, it's just weak right there. No, that's where it resolves itself. The problem is the span deflecting here and creating that stress over there. By you doing that, you'll just change this crack here and possibly push it over a few feet. And it might be enough to push it over where it starts getting captured by the next column, which would be nice. But this is why I'm a hater of this system. True hater of it. True hater. That's why I like the beams, tying all this crap together. Let's see, there's a column here. See the column there and the column there? Put a damn beam across it and do true. So across it would be under there. True distribution of the load instead of trying to distribute the entire load across a silly critical shear area. It's not just being protected by the column. So this column is showing, this failure is showing that this column and this design was correct. It didn't punch through there. It did not punch through there. You're looking at it. But what, well, I reserve the right to look at the fractures at the top to see if it had some compression breaking it. But there is no failure. With that said, there's no presented failure here. No punching through there. Critical shear area. Oh, it punched through the critical shear area. No, it's a deflection. It was the moment that created the moment over here. You needed a load, a force, and that was via the dead load or vehicle loading or cycle loading or rusted rebar that lowered its capability to keep stiffness over to there. At one point, it could hold itself. Obviously, this appears to be an older deck, and that's where we are now. Presents as an older deck. It looks like it's got a wear layer up top. All right, so what do you guys think? Hopefully this is helpful. The wear layer also can disguise what you need to evaluate. This looks like an asphalt wear layer. Now that could disguise your what you actually need to evaluate, the cracking. And you can only evaluate from the underside at that point. And on the spans like this, that would be a nice, that would be fair. But you wouldn't be able to evaluate over here. You wouldn't be able to see the cracking coming around here because it's hidden by asphalt. And you can also hide it with, say, tiles around a pool deck, tiles around the stamped concrete. Okay, so love you all. Hopefully this was informative, and I'll get more to this. I already did a couple of videos on this, and I didn't give you all the background data because this is something that's not just, it would take hours to walk you from A to B. Perhaps I can give you the short version is like this, without the background data behind it and the proof of concept to you. So you can consider that the short version. But nevertheless, love you guys. Bye.